Hey folks, Jeff here from Clark Solutions. Today to talk about the Series 22 industrial pinch valve made mostly for slurry applications. Here it is. Nice picture of the 3-inch valve with the handle kit on it. Just to give a quick rundown of this product presentation, I wanted to lay out an agenda. We're going to talk about what the product generally is, some basic use cases for it, and then we'll start getting into the details of how the product works, what makes it unique, some things we need to look out for, and then finally into how do you go about ordering it, what are some common questions that come up, and we can go from there. To start off our product overview, we have some highlights of the Series 22 valve. This is an industrial pinch valve starting from ½ inch in increments all the way up to 3-inch in size. What makes this a little bit of a solid design is that the body of the valve is separated from the wetted process by a spool that some people refer to also as a sleeve. The sleeve is the only part that's touching the process material, and it protects the valve from all the chemical and mechanical wear, but also allows you to replace that, leaving most of your infrastructure relatively put together. We'll get into the replacement of the spool later. It does require a little bit of disassembly, but overall this brings cost benefit and time benefit to facilities that need to use these valves. The design of these valves is quite unique, designed by the Larad Corporation. It uses 2 cams to roll the spool open and closed by a quarter turn valve stem. And the function of the spool and the memory of the polymer helps the valve functionally work. So without the design of the spool, without the design of the valves, you won't have a functioning material, functioning valve, but together they work fantastic. And we'll again get into this a bit later, but the spool material can be selected based on whatever your application calls for. Maybe it's very abrasive, maybe it's chemically challenging, maybe it has sanitary concerns. There could be a multitude of other reasons. And where in Massachusetts, these are made right down the road. Just something that's available for your knowledge base. Why do we want to use these valves in an application? So you'd want to use a pinch valve like the Series 22 when you have a high duty cycle application. Maybe you need on-off control, maybe you need proportional control, but these are designed to be heavy duty, give a long life, and complement the replaceability of that spool with the capabilities of that proportional control. We also have versatility in the design. The quarter turn valve stem means that you could actuate this by hand with the handle, electric actuator, pneumatic actuator, and this technology also complements other types of technology that's common for industrial usage: air operated double diaphragm pumps, larger peristaltic pumps. They fit in quite perfectly with each other from a technology perspective. Here is a general target application. Be a slurry, might be something that has to do with wastewater control, wastewater inlets, sludge, challenging media, pH control, precipitates, all these things that are going to kill other metallics and elastomers. You don't want to be replacing a valve every year because it's died again. You want to use something that says, hey, this valve will be great for a long time. All you have to do is change out the spool piece. Just a couple other applications here on this list. These are fairly common ones that we see, but flue gas desulfurization, dealing with all that kind of crap and corrosion on the downstream side of things. And here's a little bit more of a comprehensive list of some other ways that we might see a lot of things that bring these in common is the fact that they're slurries, the fact that they're challenging for most valves otherwise, high viscosity, low viscosity, things with solids in them, um, and it's not mentioned on here in this list as much, but foods, dealing with sanitary applications, of course. So we've kind of listed these in order from most common to, I think most sought out. But, lime slurries, as we mentioned, pulp, fluids, and many more, I'm sure. Here would be some benefits to the product design. The whole valve basically closes, so there's no dead zones. The spool is the only wetted part in contact. You have, as I mentioned before, a quarter turn actuator with a selection of control packages. The body of the valve is made from vinyl ester fiberglass, which in itself is fairly corrosion resistant. We all know transfer kind of happens over time, but it's also not something that's hugely expensive as a valve body material. And the fact that it is vinyl ester as opposed to maybe, say, stainless might bring other benefits as well, depending on what you're doing. We match standard ANSI flanges, and these are engineered to fit into most industrial size piping applications. We have here a really basic engineering overview of how this valve works. There's going to be a couple other pictures to show you how this operates, but you can see here, I'll turn on the pointer. We have the cams, one here, one over here. We have the spool that runs through the middle. This is just a cutaway for educational purposes. And then the stem of the valve here. Let's just go to the next one as well. Yeah, a little bit of a breakdown in the part number nomenclature, but you can see the whole valve pulls apart using these 4 body bolts. The spools are held in place, and the closure cams, you can see kind of the cutaway now that this is exploded out a bit. And you can see here, I mean, the spool design is going to be the same no matter what size the spool is. Could be 1/2 inch, could be 3 inch. It's the same basic design. And this is the element that is swappable. We have here just a little bit of notation that I added very quickly, just kind of showing that quarter turn cam direction. So they're going to roll in on each other and basically close the mouth of that spool insert, which we will see more in just a moment. I wanted to just give another angle again on how this assembly looks from a different perspective, from a cutaway, using some of the nomenclature that we have here. There's quite a few different materials mentioned in this breakdown, but once again, the only wetted material is the spool. You'll notice that a lot of these are tied to the mechanical driving of the spool itself. But there is a mention here as well of O-rings that go on the side of the diaphragm spool on either end. This is more relevant when you get into food grade applications. So here we can get into the details of how the spool works. So I'll turn on my laser pointer here. You'll note we have a little arrow here that shows, if you look real close, you'll notice that we have the little tiny channels. There's one on each side. There's one over here as well. I've kind of marked them in this Etch-a-Sketch style. And these are sort of the squeezing, the points that when the cams are closing, they're sort of the last part to remain open. And so that's kind of one of the keys on how the modulating flow control works a bit. Naturally, they're also going to be the first point to wear out during abrasive applications. But the way that it's pinched, it allows a little bit more of that fine control on open and close. and it allows overall for better flow characteristics. And I think this is a little bit of the design strengths that we see from Larad on this valve. And this is going to look visually the same on any of the spools. This is inherent to the design of them all. As these cams roll, close, and open, it's going to get pinched. I'm just doing this in the same direction as the spool piece. And as you can imagine, when you squeeze a circle, it turns into an oval, and some of the flow characteristics can change with that. So these assist in sort of helping that flow characteristic. So we're starting to get more into the details on this application, which is good. So a quick overview of how do you choose the spool material for your application. The most important is by far the wetted fluid chemical compatibility aspects. Is this acidic? Is this basic? Is this abrasive? Is this high viscosity? All these things might call for different spool materials as a result. The second one that we've highlighted is the duty cycle, the application. Certain spools might be more preferred at a high duty application. Let's say this was just for water with occasional solids. You might pick one material versus, more of a waste application. You might pick something else. The location of the valve, is this going to be exposed to UV? Is this going to be inside a facility? This also might make that decision different. You expect different temperatures. You expect other environmental factors to be potentially affecting the valve as a whole and the spool material. And then finally, is there a planned maintenance cycle on this? Is this the type of thing where you say, I want to save a buck on buying maybe a lesser quality spool with more replacements? Or do you want to kind of see if this lasts you a bit longer in your application? Kind of a combination of the duty cycle put together with your preventive maintenance cycle. Here is a quick part number matrix. We have here, as you can see, 1/2 inch all the way up to 3-inch increments. It's a little bit of a guide as to how to put together a part number. We'll get to a quick example on that after this, but the short story is if you go to the flange or spool column, if you're putting together a valve part number, it's always going to be the O1. If you're just buying a replacement spool, it'll be DS for diaphragm spool. And then, of course, actuation and options would be continuations of if you're putting a valve together. And there's quite a few more options and actuators than on this list. This is a little bit of a simplification, but this does list out the current available diaphragm spool materials and the current available flange sizes. Here's a great example, a 3-22-05-01-NO 3-inch valve with an EPDM diaphragm spool. It has a bare stem, which means it does not have an actuator with it, and it's of course that ANSI flange spec. And then the second part number, this would be that same valve above, but for the spool only, so the -DS. Now, I think there's a small caveat that doesn't get noticed very often. You can get food grade diaphragm spools by changing the first spool part number to a 2. So in this example, it'd be for that diaphragm spool part number 3-22-25-DS instead of 05. Okay, so let's get into a little bit of the competitive analysis, and I'll talk about some of the competitors a little bit more vaguely, although I'd be happy to talk about this at length if people want to hear more. Most of the competing pinch valves are only up to 2-inch, and so we are one of the few that goes up to 3 inches in the market. There was a variant of the Series 22 that actually went up to 4 inches at one point. I don't believe that it's still available, but it could be a discussion for OEM customers. Competitor valves typically actuate the pitching of the valve pneumatically. I'm not trying to imply that they only use pneumatic actuators to actuate the valve. They might have some sort of electric actuator in combination, but they generally need some level of air pressure to squeeze the tube with their design. The cam design on the Series 22 is a proprietary aspect to this. Although there are other ways to squeeze a tube, some of them, the squeezing function might wear out an insert or a tube more quickly. Solenoid pinch valves, I just throw on here. They don't go up nearly large enough to be considered, but I know sometimes they come up when people are searching. They have a very limited duty cycle at the larger sizes, and of course, they're limited by pressure of the line and everything else. If you're looking at using different other valve technology, you're going to have some challenges using other types of valves than a pinch valve. And this would generally present itself from the valve simply needing to be changed out, whether it's a chemical compatibility issue, whether it's a mechanical wear issue, maybe solids going through are going to destroy a ball valve pretty quickly. A butterfly is going to wear out if you're putting a slurry of sand through it very quickly as well. And similarly, you could say the same for any of these other ones we've listed. Now, replacing a spool versus replacing a whole valve, I would say it is easier to replace the spool, but some might say, well, I need to shut off my process regardless. If I'm able to get a cheap valve and throw it in there for another year, maybe you could accept that as well. The sleeve failure on the Series 22 is indicated and marketed. There's basically a relief valve at the bottom, and you could plan routine maintenance to replace it before it fails. But otherwise, this is designed to fail in a way to where it's going to be hopefully less disruptive. If it is horizontally mounted, then the weep hole will be at the bottom, so you could maybe put a little bucket down there. If it's vertically mounted, I think that's a little bit more complicated depending on what you have flowing through there. But at least there is a planned failure mode for this. Since I have your attention, I just wanted to mention that we do sell a few other industrial products that you might be interested in if you're looking at this presentation. A few larger air-operated double diaphragm pumps and single diaphragm pumps, some larger peristaltic pumps, some large industrial actuators, and small ones as well. We also do two-way and three-way valves across a few different valve technologies. And of course, we do pressure and differential pressure sensors and flow sensors and data acquisition. So reach out and say hello if you need something. How do I order this valve? I have put a Google form in the link to the bottom of this presentation. And alternatively, you can just send us in a sales inquiry. The Google form has a couple typical questions that we might ask about the application. That said, we're also more than happy to jump on a call with you, and you're able to talk to real people here at the office in Hudson, or sometimes they're on the road. We have people here who have experience in the applications, experience sort of otherwise outside the product. And of course, we bring hopefully a little bit of value to you with our experience, but also our warehouse and the flexibility that it provides. Other than that, thank you very much for your time, and please reach out with any questions that you may have.